Hey guys, we're going to be starting here in just a couple of minutes. So you need to get things set up. So feel free to grab your soda, caffeination, get your popcorn. This is going to be a fun one. I tell ya, the world of AI and technology, they give us fun things to talk about every day. It's literally what's up with GitHub. Yep, we're about ready to look into it, and I'm not super impressed. And neither will you be, Emils. Just wait. Yep, it is an oh boy kind of day. I tell you, farming these big tech companies has never been so easy and so much fun. I just don't understand why they keep making these egregious mistakes. Like, what's going on, guys? Why are you doing it? Don't do it. You know, just, just be ethical. Is it really that hard? Just do the right thing. Anyway, we're going to start here in just a few minutes. I just need to take care of a couple things. Wanted to get everything set up. Oh, you're at the dog park. Awesome. Take some photos and drop it on a Discord. Yeah, let me drop the Discord just for any of you that aren't on it. It is our perpetual home base. By the way, as you can see over here, this is my control center, growing every day. And we've got this whole section down here now. Whoops, not that. Not that. This. Got this whole section down here where I can enter in a whole bunch of fun things. Yara says, I'm sure it has nothing to do with the fact that that they're trying to suppress the science evolution now. AI is open to everyone. Yep. AI is becoming very quickly open to everyone, and I love it. So there's some wacky stuff. Let me increase the minutes here. Okay, so we got stuff. This will get people to flow on in. And I realized it's an unusual time, but it was so wacky that once I got done with my other things, I wanted to quickly hop on and chat with you guys about it because I honestly just couldn't wait. It's going to make us all giggle. And then anybody that's using GitHub, I suspect immediately after this live stream, you're going to log into GitHub and you're going to make a change. We'll maybe take a poll at the end of it to see. So, oh yeah, and for the Discord, anybody that's not on the Discord, you should definitely hop on the Discord. It's just so cool. We are at, what are we at now? Almost 140 people. It's growing every day, and the community is super active. There's almost 40 people on it right now, as you can see on my little command center. And there's just a hyper group of superstars that want to talk tech and help everybody become better and level us all up and keep this stuff out of the hands of the tyrants. So give me, about 8 minutes. Hopefully you guys can see our little countdown here. I want to I want to show the countdown, and I want to show my control center at the same time. You can see kind of the fun stuff on here. Cool. So grab your soda and your popcorn. We'll start in about 10 minutes. Almost ready, guys. Just need 1 or 2 more minutes, and we'll get rolling. Sorry for the delay. Just a million things today. Alrighty. Alrighty. Yeah, I need to get in Discord. I keep forgetting to join. Yeah, Yara, what's going on, man? Oh, GitHub leads to remote code execution. No, no, I mean maybe, but this stream isn't gonna go. I hope down that rabbit hole, down that road. But it is gonna go down some interesting roads. So let's hop over to my command center that I live in these days. Man, this thing is really coming together. I've got so much to show you. Check this out. So I have multiple pages in this thing now, and you have a full. I'm building essentially a full code editor and integrated system down here where it's directly bound to an AI. Right now it's Claude, but we can connect this baby to anything. And then I'm slowly getting to the point to where we're abstracting all this stuff out so you can add in any of the goodies that you want for yourself, like renaming it, changing all the sections to whatever you want. You'll be able to create your own pages. So whatever kind of pages you want. Like I've got my sponsor page for GTT, and I've got my list of streams and splits that I'm working on. But all this is going to be totally configurable. It take me a couple more weeks, and then what I'm going to do probably is just release the binaries. But that's open for discussion. But let's, what are we going to talk about today? Today, we're going to talk about what have you done, GitHub? Why, GitHub? Why? Hold on, we need to make this even funnier. Why, GitHub? Why? We love you. Stop doing these things. Okay. Then I want to talk about the control center. Fix the name of the app at top from command center. And what else do we want to talk about? Teaching on diff for first time this autumn. I've decided I'm going to teach deterministic intent folding for the first time ever at Stanford. It's going to be in this year's course. What I think we may do is actually create an entire course for it, but it's not far enough along yet to... I'm going to get voted off the island if I submit it today. So I need to build out a little bit more infrastructure before it's like world-class ready. We're on our way. But I will be teaching it this year. And I'm mentioning that because all of you Jeters are invited to come to Stanford, come to the uni, and audit the course for free. You just have to send me an email, and I need to make sure I get you on the list so security doesn't stop you at the door, that kind of thing. But yeah, if you're down with the stuff we talk about on GDT, you're probably going to really enjoy my machine programming course. Let's see. So GitHub, the control center. What else do we want to talk about? MS has patched the GitHub flaw. Michael, what flaw are you talking about? Yeah. No. Yeah. So I'm actually not even going to talk about. I didn't even know about a. Alexander, you do not. You do not need to have a college standing. You don't need anything. You just need to be a good person and promise to be respectful of the students that are enrolled. So the enrolled students have to come first, right? Since they're paying the tuition. But I always secure one of the biggest rooms at the uni so people can audit the course every year. I've done this for the last 5 years. This will be year 5, I guess. And so we have people from industry, we have venture capitalists, we have high school students that come in. Now, admittedly, I teach at the PhD level, and I don't mean this to flex, I just mean that the content's pretty heavy. So while I invite people from all walks of life to attend the lectures, just know that it's going to get down some pretty sophisticated rabbit holes if you decide to join. But yeah, I want to make what I teach at the uni available to everybody. And so that's why I do that. And that's also why I have the course material available online for everyone. Let me bring up the link to that just so you guys can see it in case you're not aware. It's very soon, this website's going to be goju.dev. We're working on that. Or the team's working on that. I'm lazy and not doing anything. But yeah, so for example, I didn't teach last year because I had a whole bunch of stuff going on. But if you go to this website, you can get basically all of the slides. All the slides are there for free. Don't have to, no, this isn't a side hustle. I'm not trying to sell you anything, right? We're just trying to make the world a better place. It's true, there are some people out there that actually just, I owe a huge debt to society and the people that mentored me, and so this is part of me trying to pay some of this back. So all the lectures are here. You can see all the slides. Unfortunately, I don't have the recordings. Yes, right, the data camp VOD is finished. I have finished. Oh, let me add that. Thank you, Sean. Let's add this. Data camp discount is live today. GTT VOD will go through DC review today. Posted soon. And that discount, I believe, the DC discount, 50% discount, live from today through May 24th, I think, something like this. Okay, so Michael's dropping in what he's... Yeah. Yeah, Dino. Yeah. Yeah. The only thing I ask for is that you join the Discord, which is free. join the Discord and be part of that, just because there's a bunch of super smart people over there, way smarter than me, very excited to teach others and share all their knowledge. So if you're not on the Discord, join that. And then if you want to become a member of the YouTube channel, it's like a $1 to $5 a month. You don't have to, but you get access to ad-free content. And eventually, once we get the membership to over 100, I'll start doing member-only VODs on really hard-hitting topics that I can't say in a public forum. And where we are right now with YouTube, I think we're about 30. I think we have about 30 memberships now, which is great. We've only been doing the membership thing for maybe 3 weeks. So we should hit over 100 members in the next couple months. And then we'll start having some more wacky. But every live stream that I do here, I immediately do post-production, level up the quality in both video, audio, and then I push it to both YouTube Open and YouTube members, but the members get the ad-free version. So even if you don't have a YouTube Premium account, which I think costs like, I don't actually know what it costs, $12 a month? Something like that. You can just have a GDT membership for $2 a month and no ads. Or you can watch the ads and then just watch the free stuff. Anyway, so on this website here, you've got all the lectures. And I usually have one guest lecture day where I bring someone from industry like Google or Microsoft or wherever, or I bring another academic colleague, some of my good friends at Berkeley or MIT, University of Pennsylvania. And by the way, I don't mean this like as an elitist thing. It's just these are kind of the circles that I hang out. I have some friends at Harvard and stuff too. And so I usually rotate. I'm trying to rotate different unis or companies in every year. I think, yeah, last year, hold on, let me find this. You guys might be interested. So you can see I did a machine programming day at the uni in 2024. Yeah, let's see if I find this. And it was like a 5-hour, I think, event. Stanford didn't want me to run it more than 5 hours because I take one of the biggest rooms and there were other people. But I had a whole bunch of people from industry come in. Let me see if I can find it. Who else was in this? Emily. Ooh, found it. I found it. Yeah. So I did this a couple years back. Maybe I'll do this again this year. And so we had this event from 10:30 to 1, and it brought a whole bunch of different people in from various places. And then the truth is we had a full, so we did the morning at Stanford, but then we did the afternoon and the evening at Murley headquarters in Palo Alto. So it was literally, we were going, I think the last dinner that IBM hosted, that went until, I don't know, all I remember is I was leaving the Murley headquarters office at midnight, and many people were still going. Like, we were rocking the whole day out. But, yeah, so this is what we had. We had Evan, Dr. Evan, who runs a nonprofit startup well, he's doing a whole bunch of stuff, but one of the things he's doing is verification. Basically, a machine programming system that's doing formal verification to make things more deterministic. Then we had Alexander Levin, who one of my collaborators in the past. We've done a couple of papers together, and he's a repeat founder, very smart guy. He runs Pasteur Labs. Then we had Taylor Dolezal, and he gave a talk on, he was at the CNCF at the time, which is one of the biggest branches of the Linux Foundation. That's where like Kubernetes and stuff came from, if I remember the lore correctly. And then we had Emily Fontaine close us out. She was IBM vice president, and she's the global head of venture capital at IBM. Oh, I guess I closed it out. Yeah, but it was pretty awesome. It was like a lot of fun. So maybe I'll do one of those this year. Anyway, I'm meandering as I always do. But back to 329M. So you've got all the lecture material, but then I also post. So I post the syllabus, and then do I have the? Yeah, I think I have some examples of some of the assignments, so you can see some of the stuff that the students are doing. Some of these projects turned into peer-reviewed publications. There's actually one of my students who literally, well, we first started working together at MIT, and then I moved over to Stanford, and he did too, coincidentally. So he finished his undergrad or something at MIT, and then he switched his PhD at Stanford. And then he took my course, and now he's running some like huge AI startup. And some of the things that he does, at least things that he's mentioned to me, are things that he's learned from this course, and, and others, right? Oh yeah, Kraska. Yeah, Kraska is amazing. This guy is, Tim Kraska is a superhero. Yeah, so then you also have the reading list. This is a little dated. I need to update this. Anyway, the point is there's this wealth of information of the machine programming course here that you can get online and see all the stuff, but you can also attend in person. Now I realize it's, not many people live in NorCal and can just drop everything and hang out with us. But if you can, if it's something that appeals to you, you're in the financial position to do it, or you're already in the area, you're welcome to hop on board, hang out with us. Cool. So let's go back to our topics. Yeah, basically what this command center is I just decided I needed an app that does the stuff that I need it to do, and there was no app that really did it. It's yeah. I think I was actually planning on having Kraska give an invited lecture, and if he does, I'm gonna make him fly his butt from the East Coast to the West Coast to hang out with us, since he makes me do the same thing. Like literally, when I taught the guest lectures for him, he literally was like, "Oh, but you have," because I taught for a full week, and he was like, "Oh, but you have to fly. You can't do it over Zoom." And so, if he's making me fly across the country to teach in his class, then I'm going to make him fly across the country to teach in mine. I mean, that seems fair, doesn't it, guys? Right? There's a lot of love going in both directions here. Anyway, so this control center is turning into, I think, at least from my perspective, the app that did not exist that I needed. And I'm going to continue to just add all this stuff and make it basically the thing that I need to organize myself that also has direct access to the AIs so I can farm out work, and then it can be reading streamed information. I mean, I'm probably going to build, like, no joke, I'm probably going to build a news feed into this. Let me actually add this to my list. I'm going to do this tonight. Add news feed page into GC to start auto pulling AI news into it daily, hourly. I'll figure that out. This thing is going to blow up, and I'm going to give this away for free so everybody can use it. I may have a premium version that's like superpower, but the base system is going to be everybody can get access to it, and then you'll be able to set it up the way that you want. But it's going to take a little time, and you're going to have to deal with wacky behavior because it's not going to be perfect out of the box just because I'm juggling surprise, I'm juggling a few different things. All right. So the topic at hand, I think this is good for our discussion. The topic at hand, why are we here? What happened with GitHub today that I felt the urge to hop online in the middle of the day and share with you guys? Yeah, that's actually a really... Ooh, I love that, actually. Hold on. I think I might just add this, Alexander. Okay. So what happened with GitHub today? Well, what happened with GitHub today is this. Let's read this together. And maybe this happened a couple days ago, but I'm just hearing about it now. In a recent update to VS Code, specifically the Git extension, the default setting for AI co-author attribution was changed from off to all. This causes VS Code to automatically append a co-authored by Copilot trailer to your Git commit messages whenever AI-generated code is detected in the changes. Okay. Hold on. There's more to this. Default behavior. The setting is Git add AI co-author is now set to all by default in newer versions of VS Code. It is triggered by any AI involvement, such as accepting an inline completion or using Copilot agent, even if you manually write the commit message yourself. Visibility, the metadata is visible in your Git history and on platforms like GitHub, which recognizes the trailer and attributes the commit to multiple authors. And here's how to turn it off. All right, so why is this something that's worth talking about? Here we go. Community response. This change has been controversial within the developer community. Many users have expressed concerns about stealthy changes to commit history metadata without explicit consent, especially as commit messages are often part of permanent project records and audits. Reports suggest that a fix or a reversal to opt-in behavior may be planned for upcoming versions. All right, let's back up a second and let's talk about how this should be done in my mind. When I was at Intel and we did this type of thing, there was a very strict rule that you always built things that were opt in, not opt out. So what is opt in? What is opt out? Opt in is where you offer something and then people say, huh, I want to be part of that. Sign me up. Opt in is like what I'm doing with the Discord, is by you guys joining the chat, I don't hack your accounts and automatically sign you up to our Discord. Not that I could do this, but, you know, it probably wouldn't be too hard to read your IG account when you join the live stream and then find a way to send you a message and then basically try to start sending you spam mail from GTT every time you joined. But I think that's kind of not great. I don't like that behavior because you guys are not asking for that. Instead, you should essentially have people choose to be part of something. That is what an opt-in is that you're letting people, you're making people aware of something, and then they say, do you want to be part of this? And you click the, heck yeah, I do. Check. Opt-out is when somebody becomes part of something and they immediately are forced into something else without their explicit consent. Let me give you an example of many opt-out scenarios. Oftentimes, you guys will go to the grocery store or your favorite clothing store, and they'll say, hey, can I get your email address so I can send you the receipt? And you'll say, that seems strange. Why don't you just print it out? And like, well, let's save the planet, man. So just give me your email address, and I'll send you the receipt. Part of the reason why they're doing that is they are setting up an opt-out marketing for you. They are essentially adding you to, in many cases, a subscription that is opting you in without your consent. So then you will start getting marketing emails from that company. And in some super nefarious cases, they add you to a global customer list and then sell that information to other people that then also add you to these subscriptions, which is why sometimes if you go shop at Banana Republic and you say, yeah, here's my email address, goju at Merly AI, suddenly you're starting to get like emails from travel.com or Expedia or whoever. And you're like, what? Why am I getting these emails? I never subscribed to any of this stuff. Well, that's because somebody, in many cases, somebody has now sold your information. Because keep in mind, it's almost always sold. They're not giving it away for free. Because in many cases, part of the sale that they're making is they're selling your data. And this is generally considered really bad behavior. Like, you generally just don't want to do this, right? This isn't super cool. So at Intel, there was a very strict rule that you could never create any kind of software or system where you automatically opted people in and they had to opt out themselves. So you automatically added all these people. Let me give you an example. At one point, I was working on the transactional memory project at Intel, which was trying to like standardize transactional memory for C++. And there were a bunch of people that were involved in transactional memory inside of Intel, as well as business partners that we had at other companies, like Oracle and IBM and Microsoft. And we had all of their email addresses. What I could have done is added all of their email addresses to the transactional memory updates that we would send out, and Intel would have sorry, what's happening on the chat? Is that yeah, oh yeah, man. I mean, Chris is asking about I think the transactional memory stuff. Yeah, we built the first hybrid transactional memory system for Haswell for the RTX, restricted transactional memory stuff. And have I not talked? Maybe you, I think I talked about this in some of the, I don't know, I talk about a lot of things. And so, yeah, totally. There's a paper we published a while back. What is it called? Heiswell. And Heiswell, am I spelling this right? Oh, maybe I just put my last name in here. Oh no, not Heiswell. In Viswell. I I honestly can't remember what the hell we. Oh yeah, okay, in Viswell. Sorry, something like that. Cool. So this paper in Viswell, hybrid transactional memory for Haswell's restricted transactional memory. This was, to the best of our knowledge, the first paper that created a hybrid transactional memory system for the Haswell transactional memory system for its hardware. And this is actually my first PhD student, I think, Irina Calciu. And yeah, we had Morris Hurley on this. And yeah, so absolutely, just super awesome, super pumped about that. If you check the yeah, you're putting it all together, Chris. So Chris is asking about SGX, the secure enclave stuff. What does that stand for? Secure guardrail extensions or something? I can't remember. But that is absolutely a precursor to the security stuff. There's all this, and there's a bunch of other things too. So keep in mind, I just to be clear, it's not like I was inventing all these things. I was working with a team and stuff, but transactional memory was one of the areas that I was driving. Anyway, so back to the. Chris is very excitable this morning. It's awesome. I appreciate the love, brother. So back to this GitHub thing. Basically, what we did at Intel is there are very strict rules on how you would do this type of thing. Is you were not allowed to ever put people in these subscriptions and add them to your thing without their explicit consent beforehand. It needed to go in that order. This is kind of an understood rule in the community. And when you see something like this, at least from my perspective, you know, I don't love this. And I want to be clear. I absolutely love GitHub. I love GitHub. I know many of the people that like run GitHub, literally that are like the people that are in charge of GitHub, and they are some awesome people. They're super great. But this move is not great. This is really super bad. And it's super bad for a bunch of reasons, than more than just giving GitHub Copilot undue credit for work that it's not doing, right? Like there's many angles where we can look at this and dissect why they're doing this. And I'm going to really try to foster goodwill here. And hopefully someone from GitHub is watching this or will watch the VOD of this and realize, oh shoot, we kind of made a misstep here. We kind of got, I know things with GitHub and Copilot and Microsoft and Codex and all that stuff. I know that it's a hard space that they're in right now. Totally get that. And they need to get more adoption, but that adoption needs to come from real places. It needs to not come from pretend. Not pretend engagement with Copilot that doesn't exist. Because that's what this is. This is, I'm gonna look at this from a completely harsh, non-friendly way. How someone that might look at this where they basically are antagonizing on GitHub and seeing this from completely the bad lens. From that lens, this is a mercenary tactic to inflate usage numbers of Copilot so they can create a marketing campaign or present this within the company that GitHub Copilot is getting significantly more traction than it really is. And that is bullshit. That's not real. And we all see right through it. All of us see right through it. I mean, the people that are at the 10,000 feet that are not paying attention, yes, they don't see it. They like, wow, oh my gosh, Copilot is getting so much traction. Holy cow, you guys had like 100 million commits in Copilot this quarter? You're on fire. Because that's what this is going to be used for. It's going to be used for a quarterly update to talk about the traction that they're getting from Copilot in an executive meeting to bolster their numbers, and it's all pretend. It's not real. And the problem with this type of approach is it always backfires because the truth will always come out. It's going to come out. And when the powers that be find out that this tactic was used to artificially inflate numbers to get Copilot to look like it's getting commits and usage that doesn't exist, people are going to get fired. Like executives, the people that made this decision, they're going to lose their job because this is some mercenary, nefarious stuff that is completely unethical. This is not how you do business. This is not the right way to do this, especially for a company like GitHub that has a pretty good reputation, right? Like your reputation matters. This is you don't want to get on the wrong side of reputation and branding because once you do, it gets really hard to get on the other side of that. It takes a lifetime to build up a really impressive reputation, and GitHub had historically done that. That I think a lot of us use GitHub because we saw it as like they're very community driven and they support open source, right? There was like the whole you can use it for free for any number of repos, and it's only when you want to use private repos do you have to pay. Like that's a pretty sweet model to support open source because it basically means that any open source project is supported by GitHub for free. That's like that incentivizes the public to want to use GitHub indefinitely. And yes, like I'm not naive to the fact that GitHub can then be mining that data to then doing stuff. This actually gave them one of the massive advantages initially to build the Copilot system, right? The Codex system, because they had all the repos, and then they might have had other repos that they might have been harvesting, like, but I won't go there. But for the 190 IQ people in the room, I suspect you know what I'm talking about. But in general, what this does is, one, everybody can see, anybody that understands this can immediately see that this is unethical behavior. There's no reason to do this. This is never ethical to do this. This is a money grab. This is a hack. This is a mercenary behavior that you do when you're selling people snake oil, right? This is what the grifters do. This is not what world-class people do. we don't, like us Jeters, we would never do something like this. This is not great. Give me 1 second. I still have a little bit of cold here, so I've got to get a little stuffed up. But so, yeah, it's a money grab, and it's principally, I think, probably being used to inflate numbers of traction, to demonstrate that there's significantly more traction with Copilot than there really is. And it's just fake. It's just pretend. And I realize that other companies, like OpenAI in particular, could very well be doing these types of things. And GitHub may be saying, well, you know, everybody else is doing it, so why can't we do it? Look, GitHub, you are not OpenAI. We all feel collectively not great things, or many of us feel not great things about OpenAI, because they've demonstrated to us who they are. GitHub, you're not them. You're better than this. You are better than this type of behavior. This is a grift. You shouldn't be doing it. And there are other ways to get Copilot users and to be able to essentially get traction for Copilot. And one of the best ways to do that is just make the product better. Build something that is significantly better than what you have today. That will get you more users, and that will get more people actually supporting the Copilot ecosystem and all these things. But hold on. So that's just the mercenary angle of like why this might be done, and probably the primary factor, right? Because like, at least from my perspective, I don't know why you would do something like this unless you had an ulterior motive. But I want to go a little bit deeper here, right? Like we often talk about degrees of separation, and how I'm of the mindset that degrees of separation is one of the most important concepts to understand, because it allows you to think more deeply about problems than than most people think about. I think I have a YouTube. Yeah, okay, cool. Look, Gemini knows. All right, so at some point I talk about this degrees of separation thing. By the way, I didn't invent this. This was taught to me by people that are way smarter than I am. And the idea of degrees of separation, if I had my tablet, I would show you. But you have the center problem, and then you have like the effect of fixing that problem, or if you don't fix it and all this stuff. But then you go to these outer layers. It's like the layers of an onion, right? And the further you go out, the further you start to see stuff that can be really important that everybody else is missing. And there is a very important thing that I think GitHub is missing that they probably don't even realize that they're doing, and it is not good at all. It is potentially heading us down the path of model collapse. It's that bad. All right? So here's the concept. One of the things that we know generally in machine learning is you don't want to train ML models on the output from other models, specifically the prior generation. You kind of think of it as like the way humans procreate. And like if you keep procreating from the same family line, then, right, you just don't have enough genetic variance, and then bad things happen, right? So the same happens with these ML models. If you just train an ML model on the output of its predecessor, then what happens is you start to overfit. It is, and that's exactly right, Nexus, it's an inbred model thing. That's 100%. That's exactly what's going on. It becomes overfit. And what overfit means is it becomes more and more specialized and fixed to this area to where it starts to lose its generalizability. It starts to lose its ability to have efficacy. When you get enough overfitting through enough generalization of degradation of efficacy, you get to this thing called model collapse. Model collapse is like a black hole. It's a black hole. Is that it's just sucking everything in and nothing escapes. When you get to the point of the model collapse, you have a model that has no value anymore. It can't do basically anything. All right? So that's the concept of this evolutionary degradation. If you continue to train the successor models on the inference results of the predecessor models, and eventually that will lead to model collapse. So people know not to do this. They know not to, well, I mean, the people that know what they're doing. There's a lot of people that, like DeepSeek did this, which I think it's well known that DeepSeek trained their initial models purely on the inference results of OpenAI and Anthropic models, which is why I think Anthropic has like banned DeepSeek or anyone affiliated with DeepSeek to even use their models. I think OpenAI is maybe even suing them for this, which is somewhat hilarious given that OpenAI did massive amounts of copyright infringement to build their model, and they're being sued by even more people. Like, it's a very strange pot calling the kettle black thing. Okay. So that's the basis of information that we have, right? And if you do this, you're going to get to model collapse. So think about coding models. How do coding models evolve? Well, coding models evolve by getting more and more human synthesized code that's of high quality that they can train their models on, right? It needs to be human written. It can't be written by the machine. What has Copilot just done? Copilot is now making every single commit that the humans are making as created by the machine. All of them. So that means the human created code doesn't exist anymore in GitHub. So then we have significantly less code to train future coding models on, because the people that actually know what they're doing, as soon as they read the commit message and it says co-authored by Copilot, we're going to say, don't use it because that's going to lead to model collapse. And so what that likely will result in is significantly scarcer data that we can train the subsequent models on. 1 degree of separation. That's all we did. We did 1 degree of separation here. How does GitHub not get this? Did they not think about this? Like, I was able to figure this out after reading this article this morning in about 15 seconds. It's crazy to me that the executives at GitHub that were doing this did not figure this out. Or, in a worse case, they did figure it out. And there are actually different commits that are being stored in the system. And this is, and by the way, I hate even thinking these ideas because this is not usually the way I think about these problems. There is a super nefarious path here, which is it's intentionally telling all the world you can't train on this code because it's AI generated, but then secretly there's actually a hidden commit message that tells us whether or not it was written by humans or by the machines, and only GitHub knows about that. That's also not great. I don't love that. I really hope it's not that. I much prefer the case where the executives didn't do the degrees of separation and they didn't realize that, oh, we made a mistake here. This could really prevent the advancement of ML. I really don't like the case that they actually figured out that, if we labeled this incorrectly, we could block everybody else from training on this because they won't know, but we will. We'll actually know the truth. And we have a separate category of scarce data that's written just by humans that only we know about. That is some serious nefarious level manipulation, if that's what is going on. I really, really hope that's not what's going on. I seriously hope that's not it. But whatever it is, this one needs to be turned off. And perhaps more importantly, for any of you that are using GitHub now, you should go into GitHub and turn this off so it stops incorrectly labeling your code now as being co-authored by GitHub. As I understand it, this is now on for everybody that is using GitHub through VS Code with this this extension, with the Git extension, which is probably everybody. So if you are, I would strongly recommend the key takeaway from this stream is go into Visual Studio or VS Code or GitHub. I don't know where it's set. I only work on like the science around building these things. I don't actually know how to use technology, so it's somewhere out there, and somebody probably on our Discord can figure out where that sits. Yeah, and you could do yourself a favor, which is what Chris is saying, and stop using VS Code entirely. Like VS Code is really going kind of in the wrong direction. At least that's what I've been seeing for a while now. So, yeah. Use it at your own risk. Okay. I'm going to take... That's basically all that I have to say. And by the way, I heard about this morning. I saw it on Insta. And then I did some checking on this to make sure that this is real. And I saw enough sources substantiating this that I'm fairly confident now that this is a real thing. It's been substantiated and reinforced by dozens of different places now of a high trust for me. Okay. That's our first topic of the day. And you can see now probably my comment. Like, again, GitHub, we love you. I really do love GitHub. I do. I think such positive things about them. They were a huge part of the open source movement and making Git usable, right? Because some of us that are older were actually coding before Git came along. So we were using things like SVN, or even worse, Microsoft Visual SourceSafe. Got some stories there where it ate the entire Notica repository, which was not great. And I'm not just talking about deleted all the code. I'm talking about wiping out the entire history of all of the code. So that immediately got me to stop using Visual SourceSafe. But that was the state of the universe prior to Git. And then, of course, Linus and company created Git, which was a masterpiece. Yeah, there was SVN, and there was, I think, CVS or something else. But there was no Git. And we really needed something like Git. And so Linus took it upon himself to create Git because he got just so fed up with everything being bad. And by the way, this is very much what motivates me. Is I basically just try to mind my own business until I get to the point where I'm so fed up with things just being bad that then I just say, okay, I'm gonna have to fix it myself. Which is like why I'm creating this thing, which is why we created Merly, which is why we created GTT. Is it's not so much a flex of like, oh, I'm gonna do this thing because I see an angle and I can grift. It's more just like, for GDT, why do all the AI companies keep lying to people and selling them this stuff that's just not true? It was driving me nuts, and then many other things. So I love that Linus did this and basically was like, we need a better source control system, which, by the way, is completely unglamorous work, right? It's not glamorous at all, but it's fundamentally important. And now we have it, and it's actually transformed the world. In some sense, I think that Git is more transformational than Linux is. Because who uses something other than Git at this point? I mean, yes, I know that there are these other systems that exist, and like, what is the... I forget the name of the other one that's really common that I think some people were using. Chris, do you know off the top of your head? It's one that exists today. I could ask the AIs, but I feel like being super lazy and just having you tell me the answer. It's like they were using it at Intel. Yeah, I think the first commit for Git is pretty hilarious. It's sort of like this, the first message on the internet was also like pretty... Yeah, so Matt, what you're talking about are the different embodiments of Git. So there's Bitbucket, there's GitLabs, there's GitHub, and there's several others. Those are all still Git based, and they're just derivations of like the UI UX, but they're still, the framework is still all based on Git. But thank you for that, Matt. You're absolutely right. Those things. But no, there's this other thing that people use, Perforce. Perforce. It's called Perforce, and I think it's pretty easy to use, but it doesn't have, like, I want to take this conversation a little bit sideways for a moment, and maybe you'll see a little bit more why I have so much deep appreciation for Linus. One of the things that I've learned in my life of just doing a whole bunch of science and stuff is how important reasoning about things temporally is. I'm super interested. Yeah, clear case too as well. Yeah. I'm super interested in reasoning about things temporally or in other dimensions just than like the typical Euclidean spaces, like Hilbert spaces. And by the way, this does sound fancy. It's not fancy. It's super simple. Like the Euclidean spaces, it's just basically a three-dimensional space. And so you have like the X, Y, and Z, if I'm remembering correctly. And a Hilbert space, all a Hilbert space is basically this dimensional space that's unbounded. So it's not fixed to just three dimensions. It can have any number of dimensions. And as you get into higher order mathematics and you start to get into more advanced machine learning, being able to reason about things in higher orders of dimensionality is super important because you can see things that are not possible to see if you were restricted to a Euclidean space. A very simple example of this is, imagine that you were just working in a two-dimensional space. So it's just X and Y. So it's just a graph. And then you add a third dimension. Well, now you can see a lot more stuff, right? Because you can turn things around. You can see it from behind. from the side, you couldn't see this before in just a two-dimensional space. So that's like what you get with adding a third dimension. Hilbert spaces essentially take that concept and they make it so it's unbounded. And this is actually a fundamentally important thing for deterministic intent folding. In fact, if I bring this up, I'm fairly certain, not 100%, but I think so. I think that I specifically talk about Hilbert spaces in the diff white paper, because it's critically important for the folding and unfolding property of where is that? The diff is deterministic intent folding, and the F is all about dimensionality changes. In many cases, it's adding more dimensions to reason about things. And most of what happens in ML today is it's a reduction of dimensionality. That's what's known as latent spaces. So if you hear someone say it's a latent space, it's just a fancy way of saying that, like, we just did a dimensionality reduction. And we've done this because it's like easier to do the computation. So again, part of what's really important for me on GTT and the way that I try to explain things is to take all these fancy words and just make them very easy to understand, right? Because and when people are coming up with all the fancy words, I promise you, they're not doing it to confuse people. They're doing it just to be precise, right? That's why diff is deterministic intent folding. And really, the fully expanded word is, or phrase, is deterministic intent-based meta-reasoning for n-dimensional folding and unfolding. But that's a mouthful. So who wants to say all that? So then the shortened version is just deterministic intent folding, and then that's still a lot. So then the super shortened version is just diff. Just diff. Okay. I found the diff white paper. We're gonna find out if I actually did this or not. I thought I talked about this. I know that Tim Mattson and I have had deep discussions about this, right? Because he's like a hardcore physicist, and this is very important to him. Why is this thing? Man, Adobe is like... I think Adobe has maybe just forgotten how to write software. Like, it is getting really, not great. Okay. I want to read this one section of the diff white paper so we can see what I'm talking about. All right. The combination of n-dimensional folding, NDF, and unfolding, NDU, when used in tandem, so what we're talking about here is doing transitions, transitionary states from higher dimensional representations to lower dimensional representations. Keep it super simple. Just think about it like changing a three-dimensional object to a two-dimensional object, right? So it's just going like this. But you're using them in tandem because there's benefits to... yeah, I know it's the worst. When I edit this actually in Overleaf, it's the black background. But I'm such a noob, I forget how to export it. Is there like a button here to make it in dark mode? Yeah, because I'm fully going... Obviously, this is not my choice of, like... This is my choice of how I like to have things. This is not a black background by accident. All right? Anyway, okay, we'll leave it as it is, but somebody can teach me maybe how to change this to a black background. Okay. The combination of n-dimensional folding and unfolding, when used in tandem, hold incredible potential for the advancement and application of reasoning systems in numerous fields, including machine learning. In particular, logical systems are designed to conduct reasoning at fixed degrees of abstraction, which currently require high-dimensional manifolds to be transformed to lower-order dimensions where many of the reasoners were intended to operate. And that sucks, by the way. Although topological and temporal dimensional folding and unfolding are a cornerstone of scientific advancement, they are principally important to diff systems. Our current and collective scientific understanding of NDF and NDU is nascent. What do I mean by this? We don't understand. We do not understand yet how these, at least I don't. And I hang out with a lot of the people that do understand this, and they tell me the same thing. It's like, we don't really understand this. Not yet. We need to, though. Okay, so to our knowledge, NDFs are limited to partial embodiments and mostly limited to theoretical explorations for folding found in higher order Hilbert spaces, yet theoretical explorations are achievable and can provide us with intuitions to guide practical applications of objects that can only be reasoned about in the high-dimensional Hilbert spaces where they reside. The translation of that from science speak to like normal speak is what I'm basically saying is there's a lot of stuff that we can't reason about in lower dimensional spaces, and so we need to put them in these higher order dimensional spaces so then we can see the hidden stuff. I'm basically saying that I'm basically saying that you can't fully understand what a car is if it's just in a two-dimensional representation. You need to have it in a three-dimensional representation because then you can walk around the car and you can understand all the stuff. Anyway, man, I was really rabbit holing there. But does anybody remember why I got into this topic? I have actually no idea where I was going with that, but I think the key thing I was trying to get at is there are certain, maybe this is where I was going, and if it wasn't, this is where we're going now. There are certain things that need to be done in order to push science and technology forward. And in my mind, diff is one of those things. And one of the most important things that diff offers us is we have to push. I was talking about temporal reasoning. So one of the cornerstones of diff is it enables us to reason about things temporally. And so we can understand things like repository lifetime reasoning. How does this relate to Git? Git has built-in mechanisms to do temporal reasoning on repositories in ways that are simply unachievable with anything prior to Git. It wasn't even possible because Linus came in and basically knew that this was going to be mandatory, so he built the structure of Git so it principally works on deltas. It doesn't work on full embodiments of the code, it just works on the delta points of the code, and that allows you to look at things over the lifetime of the repository in almost constant time. Whereas you can't do that with the systems that are looking at the whole code. That is going to be O of n time, or O of n to the m time, where n is the size of the code and m is the time slices. But the reason why it's constant time in Git is, or it's O of, maybe it's O of n time, not O of k, is that you're just looking at the source code, but then when you travel through time, it's just the deltas. It's not the whole source. So it's not n to the m, it's n to the very small number, which is basically like a 1. So it's just n. When you take Git and you combine Git with diff, you get repository lifetime reasoning. We could not build repository lifetime reasoning if Git didn't exist. Couldn't do it. We needed that as the foundation. And that's principally why the mentor system using diff technology functions primarily in Git. There's some lore, some background. Okay. I'm in outer space today, guys. I freaking love it. This is... somebody's asking if we go live on TikTok. Yeah, we're live on TikTok right now. Check it out. There is one person watching us from TikTok at this very moment. And it thinks that there's 4 people from Insta. Let's see if Insta says the same thing. Oh, look at that. Insta says the same thing. So Insta says there's 4, and the command center says there's 4. And then it also thinks there's 18 people watching from YouTube, and OBS thinks there's 15 people. And I think the control center is right. I think OBS is just lagging. But I could be wrong. Anyway, yeah, so we're currently live on all these, but a lot of people watch from YouTube. And some people watch from Insta and TikTok just because, like, they're on their phone. But then they only get to see just the portrait view. Yeah. Yeah, it could very well be that that's Andrew on TikTok watching. So if it is, hey Andrew, what's up, buddy? We miss you on the Discord. You're welcome to come back anytime. Anyway, I want to take a short break, quick bio, and then I'd like to talk a little bit more about maybe control center stuff. And then I want to read through the comments just to see stuff that I might have missed. And then we'll call it a wrap. But the takeaway, the key thing in all of this meandering is, for all of you, if you're using GitHub, and I know many of you are, you may want to go into GitHub, or specifically if you're, I guess maybe if you're using GitHub with VS Code, to figure out where this extension is and turn this off. And you're not, literally, you are not just helping yourself, you're actually helping the entire community. Because if you're allowing Copilot to flag your commits that are written by you as written by an AI, then that's less code for the future models, including models like diff, to train on, because they'll see that it's AI generated and they will say, I'm not going to do that because it's going to lead to model collapse. Yeah. Oh. T-Lock. Send me an email so I don't forget. goju@Merly.ai. And then I will forward your email to my contacts at DataCamp and ask them if they can apply it, like, retroactively. I'm not sure if they will. Oh, but I promise you, like, even if they won't, GTT will help you out, buddy. Yeah. Okay. Let's take a quick break. And we will be back. Let me see. I'm gonna check this out. I think this one's only 5. Oh, hold on, hold on. If I go back to this. By the way, uh, this was JB created this. So JB, if you're out there, he's on our Discord. He created this for us. So big shout out to JB for hooking us up with these awesome little artifacts that we can use to let people know when we're on break and not. I love it. I love all the community help. It's freaking awesome. Oh, I guess I can. Here we go. Here we go. I beat the timer. Man, I rock. Yeah. I love all the little gadgets and the gizmos that the community is helping us out with. You guys rock, man. Like, it is just legit very cool. Just give me a couple more minutes here. I'm gonna try to take my sick pills to keep me from being too sick. Yeah, it's getting pretty awesome, right, Michael? Yeah, check this out. There are different themes that I built into it. Let me just make this a little bit smaller. Not that thing, this thing. There are different themes that I'm building. This is called Batman. This is the Batman theme. And so it's got basically what I would kind of consider, or what Claude and I consider, Batman colors. It's a lot of the black, and it's got like the dark gray blue color scheme. And so by the time I am getting ready, yeah, Sean, we got big plans for you. I think that one of the first things is you helping out with some of the clips is going to be super helpful. And I know that I'm supposed to sit down and chat with you, and it's literally on my to-do list, brother. Yeah, man. So, and the way we got to Batman mode is actually kind of funny. At least funny to me, is Claude was hacking on stuff, and Claude broke some things. But in the process of breaking stuff, it created this color scheme. And I was like, hold on a second. This new color scheme is awesome. So we basically decided to start creating these different themes. And by the time I release it to you guys, it'll probably be, I don't know, 10 or 20 themes that you'll be able to iterate through, and you'll be like, just try the different themes. And then as you can see, it's set up now to where there are multiple pages that you can iterate through. Oh, and of course there is a help system built into it, right? So it's got the help that you can bring up at any point, just Control H. And then it will do stuff. You can have, it has like a built-in re-anchoring system. So as you move it around and you get into like exactly the right spot with the right size, you basically just re-anchor it. What do you press to re-anchor it? Re-anchor is, oh, where is re-anchoring? You guys see it on this list? Oh, right there. Control Shift A. We had to get wacky because with these control characters. Anyway, some of these things are just so strange. Like, I don't understand why this isn't mandatory behavior and functionality in a lot of these apps, that they don't just automatically allow you, once you move it and resize it to the right spot, that you can basically say anchor. And then it will anchor itself for all subsequent launches and not launch in a different spot. I mean, at least for super nerdy types like me, I use this kind of thing all the time. And then having a built-in ability to pin, right? Let's see if the pinning works now. Yeah, so pinning's working. So see, now it's in pinned mode, and it will always be in front. And then I can just take it right out of pin mode. So now it's out of pin mode, just Control P. Okay. Well, there's still some bugs. Hold on, let's. Sorry. I was pressing the wrong button. I pressed the wrong button. No, it works. Yeah, the pin is actually working. Anyway, I'm basically, this has got to pass the Goju sniff test in all the different ways before I release this to you guys. And my bar is super high, as I think you know. Like, I if there's one thing I can't tolerate, it's shitty software. You wonder what Alt F4 would do? Yeah, I wonder, Chris. I wonder. Okay. Oh, and there's yeah, there's like just a bunch of stuff. All right. I wanted to go through the chat history just to see if there's anything I missed. I often miss some really important comments that you guys have made. So let me take a moment here to go through this. So it looks like Insta's mostly just, oh, hold on, there are some comments on Insta. I'll go through Insta first because it's shorter. Cool. Yeah, we talked about that. Awesome. Yar's talking about joining Discord. He has now. So that's solved. Recorded live. Yep, that's exactly right. Dino. Oh, and speaking of memberships, let me drop the link for the YouTube membership in case any of you guys want to join and you aren't already members. There's the link. No pressure, but it supports the channel in a very tiny way. As we add more community members, if everybody becomes a member, then we basically have GDTCon covered, and we can start affording other things like cloud instances and hiring helpers to do clip editing, and we'll fan out more. Okay. Cool. We're through TikTok or Instagram. Oh boy. This is going to be... What have I got myself into? Where did that thing go? Oh, here it is. Oh boy. I might have changed my mind about reading through the chat. I love that you guys are so active on the chat. This just like warms my heart. It really does. I think it's one of the most important things, actually. Oh, and since I know there's many mods on right now, for you mods, and Sean, if you're not a mod, we need to make you a mod. So maybe you can remind me. I think we started talking about this, but for any mods that are on, we're starting to get like, I love that a lot of people are hopping on to our Discord, but there's a lot of people now that are like posting their availability for work, and they're posting basically their resume on the general channel and other channels. And so I created a new channel just for job postings. And again, I'm fostering goodwill. I get it. You know, I'm not trying to pick on these people. I understand. Like, we have a very strong community there's a lot of affluent people. There's many founders that are on our Discord now. In fact, I know there's probably at least 5 or 6 founders and like executive level people on the live right now. So it makes sense for people to post there. But I created this job offering channel, job offering posting, so you can post both if you are available for work, or if you want to post for a job, you put it here. And I've let people know about this. And I think, as you guys know, I really like to be soft touch because I don't like to pick on people, and I I don't want people to. Let's assume that people don't know, rather than being the moderators that like come down on people like Reddit and say things like, "This post is in the wrong thing. You're banned now." It's like, this is just, that's not the way to build a community. That's the way to just piss people off. People don't know. So let's cut them a ton of slack. But if we have people that continually like post the same job or their same skills and stuff on the general channels, then we can give them a warning. And if it gets egregious, we can basically just ask them to zip it, or there might be more consequences. But let's be very slow to get there. But I am letting people know now. So I created this, and then there were some people, it was on the general channel, wherever that is. Yeah. Where there were a few that I saw. I thought there were, yeah, so there is this guy, Tom, who posted something. Sounds like a super smart guy and doing some great stuff. I think that's great. This is not me trying to bash on anybody or pick on anyone. That's not what I'm doing here. Just showing some examples. So with this guy here. Then we have this other guy here, Blank, who posted something. And then there was another guy, this guy, Cater, that did this. And so I tried to very kindly let them know that we have this new channel, and please post this here. So I let all three of them know. And I know that there's many more. Those are just the three that I saw. And I wanted to let the mods know. So we do have a channel now for this. And I would encourage all of you guys to encourage people to drop a note to them. And if we see repeat offenders, then we'll deal with that. What I am planning on doing is, after maybe a few days, I'm just going to delete these. Because while I love that people are using GTT for a bunch of different things, which is kind of the purpose of GTT, I think there are swim lanes. So I am going to prune these out, since they don't have really anything to do with the discussion. But I want to give them some time, in case they don't have a backup of their message, to put it over in the right place. And then all of you have my permission to do the same. But again, let's just try to err on the side of being super nice and fostering goodwill, and just being very slow to throw down on people, right? Because there's a really good chance that they just didn't know. And yeah, I think you guys know what I'm talking about. Okay. Oh, cool. Yeah, JB, I keep forgetting that Vividverse Ventures is your account on YouTube. I'm trying to do the... Wait, Chris, you didn't know that I worked on standard C++ transactional memory? Maybe I... Yeah, buddy. 7 years. Uh-oh. Almost out of soda. I was the chair of the specification committee for transactional memory at Intel. Intel, IBM, Oracle, and Sun Microsystems, I think, for a few years. And then I helped kind of promote the group to move from just being the specification committee to being a standards committee. And along with Michael Wong and some other C++ people, we got SG5 created, Study Group 5 for transactional memory, at which point Michael Wong took over as the chair of the committee because he's more deep in the trenches with ISO, C, and C++. And then I became the vice chair at that point. And so, yeah, man, I was... Here, let me just do a quick... Nope. Let me see if I can find something here. So, where's the zoom? There it is. So at this point, we... Yes, this is part of from the working group, I believe. And yeah, so here's me. And yeah, this is all part of... Yeah, this is when Michael took over. Once we got into standard C++, and then I worked with them. Yeah, I basically chaired the group for this part. When we were doing the draft specification for this is the part that I was driving from Intel. But then once we promoted it to standard C++, we handed it off. But yeah, I worked on that for I think 7-8 years, actually. And I think we're an optional feature. I have a couple of VODs on this, in case you haven't seen them. You may not have seen a lot of the prior ones, but... Yeah, brother. Just like you, I dabble. I've got my fingers in too many things. And by the way, Chris, I'm pretty sure you're supposed to be asleep right now. I don't know what you're doing being on right now. Okay, cool. Oh, software guard extension. Thank you, software guard. You guys are awesome. You guys are hilarious. Yeah, no doubt, right? Like, unlikely. Unlikely. This comment right here. Because what would he have to say? Not much, I suspect. Unless it's about just hocus pocus nonsense. But yeah, we're that is what we are here for, folks. Is one of our core premises for existence is to help course correct that, and we are absolutely doing it with GTT. Like I literally had a conversation with Chris this morning, and we were talking about this, and we're on our way. This is just the beginning. Because we've only been doing this for like a year, right? oh, we've got some serious momentum for only doing this for 1 year. There's some serious ballers that are joining the movement because I think a lot of us see the same thing. You know, that was one of the things that I observed, and part of the reason why I wanted to create GTT is I felt like there was just too many mercenaries. There were too many people that were trying to use AI just to make a quick buck, and they didn't really care about the science, or they knew nothing about the science, and it's just a money grab, and not for me, guys. We're literally sitting on, at least in my lifetime, this is the most monumental technological pinnacle that I've ever seen, and I'm likely ever to see in my lifetime. And I've lived through some pretty amazing things, right? I mean, I lived through the invention of the internet. That happened in my lifetime, and that was huge. Internet's still huge, but I think the AI revolution is even bigger. And I do think the AI revolution is going to do things like get us to Mars. Like, I can explain it. And this isn't nonsense. I'm not talking about this from an ideological salesman kind of way, as I think a lot of people are. I can explain how you would use AI to get us to Mars, because most of the challenge in order for us to get to Mars, it's not a materials problem, it's not a production problem, it is a software problem. Is that we have massive software infrastructural systems that have not even been started yet. I'm not talking about like they don't work. They don't even exist yet, guys. The air recycling filtration system that basically is going to take the air in the spacecraft that's going to like support life of thousands of people, hundreds of people, whatever, for like these massive space stations that are going to need to exist, that are going to be in orbit outside of the planets. Those systems for supporting life, those life support systems, no one has even built the first versions of those systems. And AI is going to help take us there. Not this large language model, stochastic mumbo jumbo, but deterministic AI that is going to build us reliable software that is iterative, refinable, and it will use language models for creative ideation, but they will be aligned for hard science, iterative refinement. And part of the reason why those software systems didn't exist or haven't even been started is that the dream was so far away from us. It was so out of reach. It's like, why would you even bother? It's not that far out of reach anymore, right? Like, okay, let's take this command center that I'm building. I'm literally fiddling around with this for an hour or two a day, tops. Probably even less than that. What I've been able to build with the help of Claude Code and some other things is I'm literally 1,000x engineer now. I move 1,000 times faster than I did before. Now, admittedly, you have to really kind of know what you're doing in order to build something like this that is iteratively refinable, because there's so much time putting on the guardrails. But once Claude Code or these other systems have diff built into them, they're going to be way more reliable. Way more reliable. And then we will be cranking out these types of software systems, but for the software that we need to actually get us to become an interplanetary species. Like, the one thing that I know this is going to sound totally crazy. I fully understand this, and many people have told me I'm nuts, or they just don't believe me. But I think some of the people that actually know me know that, like, when I say this, I'm not kidding. This is actually what I really believe. One of the key things we were doing with Merle and now with GDT is I want us to get to Mars. Not in an Elon Musk kind of way, not in a I'm just saying things. And Mars is a metaphor, by the way. I don't care if it's Mars or if it's the moon or if it's whatever. If it's another planet outside of, you know, our solar system. Those details don't matter. What does matter to me is we must become a multiplanetary species. We have to. If we don't become a multiplanetary species, there will be an extinction event. It's not a question of if, it's just a question of when. It will happen. And if we aren't a multiplanetary species by the time that event happens, the entire human race, as well as all the other species of this planet, will be completely wiped out. And I think we should do everything we can to not let that happen. That's what I very strongly believe. And I think the technology is reaching a capability to where we can start to actually think about these systems and start to build these systems and do this in my lifetime. This is essentially one of the core chart, and this is why we need machine programming. I can't write the code myself. Chris can't write the code himself. None of us humans are capable of writing the volume of code that we need for all the systems. Keep in mind, the software systems that I'm talking about, these software systems are also going to be the systems that are designing the hardware, that are doing all the stuff that's related. They're going to be building the robots so the robots can go around and then build the spaceships, right? Like it all stems from software. And the reason why it stems from software first and everything else is secondary is we can do iterative refinement in software much faster. Software is far more forgivable in mistakes. We have a bug in it, we just fix it and we iterate, and then we can move much faster. That's why all hardware is first, it first exists in software, right? I spent over a decade at Intel. This is how you build hardware systems. It all starts with software, and then once the software is figured out, then you build the hardware. Because by the time you're building the hardware, you cannot get it wrong. Hardware is far less forgiving than software is. So now we have the superpowers of AIs. Right now they're not cost effective because they draw way too much power. That's a problem with language models, but it's not a problem with small language models, and it's not a problem if you complement them with diff. If you start to use diff as the foundation, it can prune out and eliminate a lot of, I speculate that with the right combination of the right diff systems that complement the neural systems or other stochastic systems, we can elide away 90% of the compute overhead that exists today. And now, language models at scale in ubiquity is possible. Yeah, man. Yeah, Chris, exactly. Right? Like FPGAs to ASICs to whatever, like all of this stuff. And think about like the future of FPGAs, right? Imagine if we had AIs helping us design the FPGAs so they're far more efficient and they have more capabilities. And the FPGA has a built-in system for AI that's customizable for the domain of the software that it's going to be running, right? Because as we know, the different AIs have different requirements computationally. So if you have an FPGA that has a specific AI configurable hardware component, that's something that, to the best of my knowledge, does not exist today. I mean, yes, there are TPUs and other things that people are building, like what Grok was building. I also want to say, too, and this is me not bashing on NVIDIA, is it's my strong conviction that GPUs are absolutely, like, not the right approach for AI at ubiquity. At least not for inference. They may be for training, but not for inference. And that means that you need significantly more specialized hardware. On top of that, I think that we can still make significantly better hardware for language model training. And shaving off the overhead by 50% by creating hardware that is specifically designed for AI, right? No matter what NVIDIA tells you, their GPUs were not specifically designed for AI. Their GPUs were designed for video games. That's what their GPUs were designed for. It just happens that video games do a huge amount of linear algebra for like all the rendering and all the stuff, the shaders and all of these thingamabobs, all of the geometric things. And so does ML. Neural networks in particular are foundationally represented as very complex linear algebra problems. So if you have GPUs that are really good at linear algebra and AI that is fundamentally, at least neural networks, fundamentally linear. By the way, diff is not fundamentally linear algebra. Diff is not linear algebra at all. It's something completely different, which is part of the reason why diff rocks so much is, and I don't mean this as a flex, I mean this was like an intentional design decision. When we were inventing diff, I was like, I wanted to be able to use commodity hardware on CPUs that don't require a $50,000 GPU because there are CPUs everywhere. And if we could figure out how to do that, and so we have that. Basically, the next step is, and I know that NVIDIA is working on this, I just don't know to what extent, is, and supposedly Meta's working on this. We know Google's working on this because of their TPUs, that you have more specific hardware that is aligned for the training and inference of AI models. So they essentially become application-specific integrated circuits, like what Chris was saying. And you can do that in a variety of ways. You can start with an FPGA, field programmable gate array, or you can start with the CGR array, coarse grain resource allocator. Either of those will work. And then you reconfigure those so they become specific for the application. The problem, though, is both of those designs are never as fast as burned-in silicon. Any reconfigurable hardware still has an overhead that there's a penalty because of the layer of abstraction. So, I mean, I'm not saying it doesn't work. It does. And that's probably a really good step in the right direction. But I think an even better step is to figure out the hardware design that is specific to a very narrow AI methodology, and then build that hardware just for training or inference. And if done right, I think that you can reduce the computational overhead, essentially the extra work that is being done right now, that is like being exercised in the hardware, that's not necessary. And the reason why that extra work is being done is that those primitives existed in the hardware right out of the gate. And so we're reusing existing hardware elements, functional units, that were designed for something else, and we have a different goal in mind. So they still work, but it's like overhead, right? It's like it's like you could take your car to drive to your neighbor's house, like the neighbor next door. But that's not what cars were actually built for. And there's going to be a huge amount of waste if you use a car for this purpose. Instead, if you invented a different mode of transportation, like walking, or an EUC, or I don't know, just, a bicycle, just you name it, a skateboard, that actually could be more efficient than this other thing. So anyway, there's a whole bunch of stuff that I think we're on the precipice of being able to do. But it requires us to, one, rethink a lot of the core primitives of how all this stuff works today, and instead how it should work. And then on top of that, it also requires us to deeply look at, I mean, basically it's the four, what it is it's the four domains of machine programming. I think. Let me bring this up. Because it requires us to look at all four of these things deeply and try to reassess how we would design these principles of these domains in a way that is the most effective for becoming and like really leveraging AI. Right? Like it is purpose built, essentially, is what I'm saying. And right now, almost, with the exception of diff, almost none of this stuff was purpose built. Even language models. Language models were purpose built for natural language, not programming languages. That's not what they were built for. They were built for natural language, and I think they do pretty well with natural language. And then people, you know, natural language, programming language, they both have the word language in there. Surely this is going to work. I mean, kind of, but that's not what it was designed for. And so there's like a lot of problems with it, especially in terms of efficacy. It's nowhere near the most efficient system that you could have. But let me try to find this. Anyway, as I'm explaining this, hopefully you guys can see. I'm not kidding about this. I have thought about this a lot. And this is what I really want us to do. I'm going to spend every waking moment of the rest of my life working on this. And we may never get there, but it's not going to be from lack of effort. And I'm not going to freaking build machine programming systems that are going to trade stocks and shit, or like find new ways to funnel money to me. I don't care about that crap. It's a royal waste of my time. Other people can do it. That's fine, but that's not what I'm going to, that is not at all what I'm going to do. And with the collective that we're building in GDT, because I can't do this alone. I need incredibly brilliant, motivated people like all of you. I need Chris. I need Sean. I need JB. I need Kyle. Alexander, it sounds like you're starting to become locked. Matt, I think you're starting to become locked. Like, we have to do this together. This isn't a one-person job. But we need people that actually deeply care about this. By the way, this is just a funny aside, because this. So I show this slide in my class. I show this slide, and then I show this next slide, and then I ask my students, do you know who this guy is? Does anybody on the chat know who this guy is? I mean, Chris, I know that you know who this guy is, so maybe you don't say the answer. Does anybody else know who he is? Who this dude is that's talking about auto-regressive LLMs suck? Yeah, man, this is it. This is, everything is moving toward. Yes, that's exactly right. This is Jan LeCun. This is Jan LeCun. And the reason why this is so hilarious is this dude right here has dedicated his life to machine learning and inventing many of the foundational systems that exist in neural networks. And large language models are a specific type of neural network. They're transformer based, which is basically a sequence to sequence model that is derived, essentially from long short-term memories. And this guy literally is one of the pioneers. So it's hilarious to see this dude who's dedicated his life to neural networks basically saying neural networks suck. And he's not wrong. I don't think he's wrong. And I like what he says here is what they're good for: writing assistants, first draft generation, stylistic policy, and code writing assistants not good for producing factual and consistent answers. Yes, language models can never be relied on for factual information. I want to be super clear with what I'm saying. I'm not saying that they can't produce factual information. They can. They cannot be used reliably for factual information because of their hallucinations, which is basically a byproduct of spherically constrained stochasticity. F it. I'm gonna take us down some rabbit holes. I do need to finish the Data Camp VOD, and I've got to get that like soon, but we're so into this deep dive. I'm gonna get into it. All right. So this is the talk that I gave at Microsoft Research. And hold on a second. I need to figure out what the heck is bombing on my CPUs right now. Oh my gosh. Like I freaking love these guys. These are the guys that do the video editing, and they're really good at creating editing software. They do not know how to write software that actually functions. This system, that thing that's running silently in the background is burning the CPU the whole time. Why? You're not doing anything. Okay, and it looks like one of the other things is I have too many thingamabobs open. So let's close some of these thingamabobs. Oh, that one I need. No, I think I can close this one. Yeah. I think it was, I think what was really killing it was the Wondershare. It's still running a little slow. Anyway, it's a little bit better now. The other thing that's really churning on the CPU is OBS, but OBS is always doing that when I'm streaming. Everything else seems pretty good. Okay, cool. So look, one of the fundamental things that is very important to understand fundamentally about neural networks and any stochastic machine learning method is the notion of spherically constrained stochasticity. It's fundamentally important. I teach this now. It took me a while to figure this out, and I think most people don't get this. This thing right here. Spherically constrained stochasticity. This is a fundamentally critical... Yeah, I'm thinking about it, Chris. Especially now that Steam is running on Like, I need to at least believe that Linux can run video games, even if I'm not going to run the video games. Or I can just dual boot this. Okay, so neural networks are stochastic systems. No matter what anybody tells you, if they tell you that they're deterministic, that is not correct. That is fundamentally wrong. And I'm not talking about the temperature and any doodabs that you can fiddle with to get inference to give you perfectly reliable results. I'm not talking about that. Even if that were possible, the fundamental properties that are required in neural networks to get them convergence on training requires stochasticity. It requires it. If you do not have stochasticity, then you lose one of the fundamental properties of convergence. And by convergence, what I mean is it can learn stuff. It converges on the answer, right? It's like it finds that 2 + 2 is 4. It must be stochastic to do this. Now, there's a critically important notion to understand for all this to make sense. And for some reason, people aren't, I don't know, maybe I haven't yelled this from the rooftops enough. They keep talking about this hallucination thing and whatever. What it really is they are spherically constrained stochastic machines. That's what they are. Spherically constrained stochastic machines. What does that mean? What it means is, come on, Adobe. What it means is this. This is what it means. Okay, let me make this a little bit bigger. I haven't had time to publish a paper on this. I've been too busy doing other things. But I teach this at the uni now. I've given many talks about this. And so I guess maybe not enough people know about this yet. But in my mind, this is the way that you need to think about neural networks and language models to understand what really is going wrong. You have to get this into your head. All right? Now, what are we looking at here? Okay, this whole sphere here is the entire range of answers that a language model can give you anytime you ask it a question. Anytime you give it input and it's going to give you inference, the answers will reside inside of this sphere somewhere. Okay? That's the first piece. So right here, you have the input. It goes into the language model, and then what is the output is this is the range of all possible answers that it can give. Think of it like if I say, what are the numbers between 1 and 100? You know exactly what that is, and you could give me the whole list of numbers, right? So the same thing is happening here, is that we have a fixed space of things that are possible for the answers for any neural network. All right? When we say the word hallucinate, it's a very confusing idea that I think gets people to think the wrong thing. So it's almost like when we think about hallucinating, it's like it's supposed to give this answer, and then it just goes off and drifts and has this other answer. And so you may think in the back of your head that it can come up with anything. It can't, because it's math. It's all math. So it can't just hallucinate new things that it that's not in its set of predefined answers. That's the wrong. This is why hallucination is the wrong word for this. Is it makes us believe that it can. Hopefully, this is making sense, right? Is this making sense in the chat? Like, at least for the people that are like really paying attention, you guys like grokking on this idea why it's like fundamentally different, because this notion of hallucination is the idea that you are given something and then you could give any answer. That's not correct. That is not what's happening. It cannot give you any answer. There is a very fixed range of answers that it can give, and what it is doing is it's giving you the wrong answer. All right? It's an error. It is not a hallucination. It's an error. Okay, perfect. So this is the range of all answers, and many of the answers here are errors. And so when an LM gives you an answer that is not correct, that people say it's a hallucination, it's not. It's just that it's giving you an answer that is within the spherically constrained stochastic space. So let's break these words down. Spherically, well, it's really geometrically, but it's going to be too complicated to draw that picture. So a sphere is an easier way to reason about it. It's constrained. How is it constrained? It's constrained by the things that it's been trained on. That's where the constraint comes in. So if you give it different training data and it has like a different topology, it's going to have different constraints. This is going to change from model to model. And what is the stochasticity part? The stochasticity is the amount of like random perturbation that you have in the neurons or other things that exist in that topology. Another way to say this that's like simpler is it's the amount of weirdness in the doohickeys. All right, so just think like a neural network has a whole bunch of doohickeys, and those things can come in different shapes and sizes. So those things are directly controlling and contributing to the stochasticity that you're going to get. So all these words basically are saying you have a geometric space of answers that you can get from a language model. It is constrained, though. It's not unbounded. We know exactly what it is, and it's always going to be within that range. And it is stochastic because the ML method that you're training on is inherently stochastic. Okay, perfect. Yes. Okay, and so the reason why I take issue with the word hallucination is I don't know enough about human physiology and how our brains work to really understand this from the human side, but I do understand machine learning and our science in that space. And I guess what I'm trying to say is it may be possible that humans can actually hallucinate and come up with stuff that is just in outer space that like has nothing to do with anything. It's almost like we think a new thought, and that thought came from, I don't know, just this genetic information that's passed on from our ancestors that has nothing to do with information that we were provided, right? This is like the really important distinguishing characteristic is that I think that it could very well be possible that humans could hallucinate in that they can come up with answers to things that they have never seen themselves before, right? This is like a really critical division between spherically constrained stochasticity and true hallucinations. What I'm trying to get at with the true hallucination, again, I'm not an expert in psychology and neuroscience and all that cognition stuff. Like Chris knows this stuff way better than I do, but there is data emerging in the scientific field where, like in the various scientific fields, that show that through the through our ancestors and through our genetic makeup, there's information that's being transferred from human to human as we, have sorry, there are too many thoughts, too many words conflicting. As we continue to have generation after generation, that one human could hallucinate something and say something or do something that they've never been trained on or seen before. Right? You hear of these weird instances where someone knows some Latin, or they are able to do mathematics that they've never studied, right? Or things like this. Those would, I think, be true hallucinations in that nobody has even an explanation for it. What machine learning systems do, specifically transformers or neural networks, is not hallucination. It is an answer in a perfectly defined space that is constrained entirely by their training. Entirely by their training. It has to do with their topology, the training method, and all these things. And so therefore, it is not hallucinating in the true sense of the word. It's not... So I'm really beating this horse because you need to really understand this, because in order for us to understand how to fix this, we need to perfectly understand the constraints of this system. This is math. This is all math, right? So now, with this, you think you understand that this is the entire space of all possible answers, and it is constrained by the training and the topology, and the answers that it gives are errors due to the stochasticity that is inherent with its training. It's inherent with its training. And yes, it may have to do something with its inference, but I don't even care about that part. You could make inference perfectly deterministic, and it's still going to have stochasticity because of the training part. And the training part is really important because the training part directly inhibits our ability to advance the models. A lot of people maybe are thinking, well, I only care about the actual model itself being deterministic, and so if I turn the temperature down, then everything's going to be fine. Yeah, 100%. You could totally do that. But that's not going to help you long term, because you're going to have I'm going to use the phone metaphor, you're going to have the iPhone 10 and the iPhone 11 will never arrive. Why? Because the model itself is stochastic and the training is stochastic, and so they can't reliably improve the system because it doesn't support iterative refinement. So sure, your inference answers are now giving you a deterministic thing, but that technology is cooked. It's plateaued. This is actually what's happening in language models right now. I was trying to explain this to people 4 years ago, and everybody basically voted me off the island. But they're not voting me off the island now, because they're all seeing it. Right? That's why things like Mythos are happening, where they're saying, oh, this is so amazing and this technology is going to change the world, and then suddenly it's like, wait a second, Mythos kind of sucks and it's not anything big. Yeah, because you're trying to make advances in science using stochastic systems that don't support iterative refinement. Iterative refinement is like the number one key principle that you must have for any scientific field to advance. If you don't have that, it doesn't matter how amazing the technology is, because 100 years from now, that technology is going to be the same. And think about that for a second. Like, what technology of what kind of thing do we use today that we were using 100 years ago, and it's still sufficient in the form that it was 100 years ago? Let's take music for an example. Do people still listen to music on vinyl? Like, do you have record players? Probably not. Why? Because we've used advances in that field that are iteratively refinable, and we've progressively made it better and better and better. Okay. Now, this is maybe the next most important thing, is inside of this sphere, there are clearly wrong answers, but mostly in the world of science, even hard science, is the degrees of correctness are gradients. There are gradients of correctness. So for example, if I ask you guys, what's 1 plus 1, and somebody says 10,482,000,000, and then somebody else says 3. The number 3 is, in terms of gradients of correctness, much closer to the right answer than this other thing. And if you think that this doesn't exist in the real world, all you need to do is just study how floating point numbers are actually represented and exist in von Neumann machines today. It's all approximation. There literally are numbers we cannot represent with our floating point standards that we have in hardware that are wildly simple. Like the number 0.1 cannot be perfectly represented with the hardware that we have today because we use approximations to do floating point representation. So there are, when I talk about degrees of correctness, this exists almost everywhere. Almost all of hard science is actually a nines problem. Like except for things that are perfectly in the theoretical space where you have all these givens and everything's like completely understood a priori, and you're living in basically this entire sandbox world and it's an ivory tower and it has no practical value. Like it has no, it can't translate to the real world. And only in those cases can you get to things like, oh, this is a formal proof and I can show this like every time. Like, sure, awesome, fantastic. And then you go and you build it in the real world and then it's not correct. Right? It becomes the nines problem. All right. So why is this important? Why am I really going off on this? When you start to think about language models like this, and neural networks like this, and machine learning like this, what you start to understand is that in the range of output that you can have for these models, there are varying locations in these geometric spaces that are giving you higher degrees of confidence of correctness than other areas. And that basically has to do with how well the model has converged on the answer. So if you're any of basically the dark spots here, that's basically you're wrong. And the further you are out from the center, the more wrong you are. But there are pockets in this that it's going to be right. And I'm going to show you an example of that in a second. But again, keep in mind, in almost all spaces, there are degrees of rightness. It's not so easy to just be like, oh, that answer is right, and that's the only right answer. Like, especially when you think about code. Think about code for a second. Is there a right answer that's like, it's only this answer is correct? No. Almost any problem in computer science can be solved 200 different ways. And the rightness of the answer largely is predicated by what matters for the problem you're trying to solve. So are you trying to make it super efficient for the amount of memory it'll use? Are you trying to make it super efficient for its execution time? Are you trying to, there's like a million things you can think about. Anyway, any stochastic ML system that you use, is going to have inference that is severely constrained stochastic. And what we want to do is take these stochastic machines and get them closer to this. One of the things you can do to get them closer to this is use diff. Diff can get you closer to this. It can be used to complement these language models to get them closer to the center and also to shrink this space down. What you really want is you want a stochastic system, like a language model, that has this SCS space, but it's super tiny. It's like this, it's just this dot. And basically, all of the answers that it's going to give you are going to be in the correct space. Like if we were able to shrink this down to just this spot here, basically what you would have is a language model that would always give you correct answers. But now it's just a question of like which gradients, which dimensions of correctness matter to you more. So think about it again in terms of code. Let's say that there are 4 dimensions: security, performance, maintainability, and modularity and readability. Security, performance, modularity, and readability. All 4 of those are things related to correctness, and different code answers could have different degrees of correctness in that space, right? You guys can probably already all see this in your head. Yeah? Okay, so now we bring in diff, and diff can be used to level up any of these language models in a variety of different ways. Kind of right out of the gate, there are 3 main ways that you can use deterministic intent folding to make language models better. Because unlike Jan, who I think, and I haven't been paying that much attention, so I don't actually know, but it sounds to me like his world model stuff is kind of going completely against language models. It's like just not using language models at all. And let me know if I'm getting this wrong, because truthfully, I haven't actually been following. Because, I don't know, Jan, I think he's a very smart guy, but I think that the problems that he's solving are different than the problems that I'm solving, so I don't care as much. Okay, so you have these 3 areas where you can use deterministic intent folding to make language models better. Let's look at these 3. So here's the 3. You can use it for pre-model data curation. You can use it for in-epoch error correction, so actually in training. And you can also use it for fidelity improvement on the inference. And by the way, this is me just like, I don't know, I spent 15 minutes thinking about this, because diff is an entirely new methodology of doing machine learning. The application of diff to make language models better is like this small in the space of all possibilities of diff. So I haven't been trying that hard, I guess is what I'm saying. I just was like giving this talk to Microsoft, and they use a lot of language models, and I was like, okay, well, let's talk about how our stuff can be used to just make your existing stuff better. There's also the argument or the view of like, what can diff do entirely on its own, or how it can be used to complement other types of machine learning systems, which is, it's enormous. All right. Before I dive into this and explain these 3 things, one, does anybody in the chat, since now we're getting really, let me back up. Now you guys can probably start to understand why I'm saying I might need to teach an entire class on deterministic intent folding. Is that we just literally spent, what we spend? Like 30 minutes just talking about how hallucinations are wrong, and what we're really talking about is spherically constrained stochasticity. This is an entire lecture, right? The concept of spherically constrained stochasticity, I'm not going to say that I invented this, but I discovered this idea as I was deeply investigating language models. Other people may have made the same discovery. I don't know, but to the best of my knowledge, in the literature, this is not known. But this is part of advances that we need to make in the entire space of machine learning, and being able to further constrain, make smaller. SCS is one of diff's superpowers. Okay, so 2 questions before we go into how you can use diff in these 3 spaces. 1, does this make sense? And like yes or no, and if there's any no's, like what are you stuck on, so I can explain it. And then 2, do you have any burning questions that you really want me to answer before I explain the 3 different ways that you can use diff to improve fidelity of language models? And Life Labyrinth, that's awesome, man. That's great to hear. And while we're chatting, let me drop the Discord link in case you're not on the Discord. Feel free to hop over there and chat with us more. Like, by the way, what you're seeing right now, this is like full Goju mode. This is me, what I look like when I'm getting really locked. This is what happens when I get really deep into the lectures and I'm not fucking around anymore. I'm like really getting into the science. And it takes a while for me to get into this state, but once I get into it, man, like, it's like we're serious rock and roll. Okay, I'm going to give you guys a minute to think about that. If you have any questions or anything, quick bio, I'll be right back. Okay. So Yara is grokking it. Yes, I can see it. That's the part I'm figuring out, how to use quantum PCs to make the algorithm to keep the reasoning in the center, to center the ball. Yeah, and Yara, I'm not an expert in quantum, But I hang out with a lot of people that are, and like literally, their PhDs are in various aspects of quantum computing. And what they tell me is we are very far away from having any kind of real quantum computing device. That almost all of the things that you see in the news are basically just marketing BS. Now, again, I'm not an expert in quantum, so I don't actually know. But these are people that I trust. These are literally people that have like gotten a PhD in quantum computing or whatever the disciplines are from places like Stanford and MIT. And they're telling me that. So just something to be aware of. And that's not to say that you might, you could very well be on the verge of a massive discovery. So I'm not trying to be Debbie Downer with you or anything, because I'm not that guy. Oh, JB, yeah, I can explain this. I can explain how it will. So JB's question is regarding diff is how it would evaluate the truthiness of inputs in a sense. 100%. Yeah, I can explain this. Not sure if it's part of the IP. Is it? Yeah, I mean, so right now, deterministic intent folding is closed, but I'm going to open it up. Right. I mean, I'm going to teach diff for the first time this year at the uni. I'm going to have a couple lectures that explain at least the core fundamentals of diff. It probably won't explain the exact embodiment of diff that exists in Mentor today. That's all NDA, but the core principles of it is, yeah. So Chris is part of Merly now, and he knows. So Chris, like diff is real, right? I mean, diff, you understand. At least you understand the embodiment of diff inside of Mentor now, right? I mean, this isn't make believe. It's a real thing, and it works, and it's pretty badass. I mean, it took me a decade to figure this shit out, guys. Like, this wasn't like I sat down one night and figured out the answer. It was just iteration after iteration after iteration before figuring out how to build a system. I mean, what I did first is I figured out how you could build it, and then what I did is I started to iterate out and back up on figuring out how you could generalize it. So I didn't figure out how you could generalize diff first. I figured out how you could build an embodiment of diff first. And then I tried to figure out, okay, now how can I make this generalized? And I started stepping back and back and back. That's why you had Mentor. Mentor existed before diff existed, because I didn't even know what I had invented. I think a lot of scientific advances happen this way. Is you kind of you build something and you're like, oh, this is super cool, this works, and you don't actually even understand the ramifications of what you've actually invented. And then you start to work with it more and you realize, wait a second, this is way bigger than what I thought. It can be generalized in all this way. Or you realize, oh shoot, there are some major weaknesses that this thing is actually, I'm cooked, and this thing is not nearly as awesome as I thought it was going to be. I literally have done both, right? Where I've built these systems and I thought it was going to be super awesome, and then it turned out to be like, yeah. In fact, the majority of the things that I come up with are kind of a wah-wah. Yeah. Yeah, absolutely, right? So Chris, I think, gets it to the point now to where he can connect all the dots and see what the true potential of diff is. And it's significantly bigger than what I can explain right now or the current embodiment that exists in Mentor. Like, Mentor is basically 1% of what diff's true capabilities are. And that's and Chris has like Chris, do you have like a PhD in neuroscience or some nonsense, or like what's your anyway? The point of this, Chris is super smart, and it's like there's a lot of background before it will fully make sense, and this is not a flex. This isn't above anybody's head. It's just you can't do calculus until you deeply understand trig, and you can't do trig until you deeply understand like geometry. And you can't do geometry until you deeply understand algebra, and you can't do algebra until you deeply understand arithmetic, and so on and so forth. Right? It's yeah. So PhD in neuromorphic computing. So he spent his life doing this kind of stuff, and he's one of the few people I've met that actually understands diff, and it's because he understands the theory so well, because it's the theoretical implications of this that are really transformative. Anyway, okay, sounds like we understand. And Plastic Designs, super awesome that you found us. And hello from us in the U.S. We love that Holland is part of the party. Okay, so let's quickly talk about the 3 ways that you can immediately use diff to deal with SCS, right? This is like, so the question, we have this SCS thing, and so all this is just problems. All I've done is I've explained the problems of language models in a far more precise and clear way than just saying it's hallucinating, because that's not helpful. It's like, what does that even mean? SCS is a way that we can reason about the errors and the correctness of the inference for language models. And once we can do that, we can start figuring out how to make it better, which is why SCS is so important. All right, so the 3 ways it can be used. All right. The first is with the pre-model. So it is before it hits the model and before the model even exists. Although truthfully, you can do this when the model exists as well, and you can do data pruning and change the data that goes into the model for inference. But in this case, let's just assume that is you're training a model, and before the data is sent to the language model as ground truth, what happens is you intercept it with diff, and then what diff does is it does an analysis on that data to understand its correctness, its like truthfulness, its truthiness, and things that diff immediately can classify as erroneous, it rejects. It doesn't even let that data go forward. So how does this help? Well, if diff is able to elide away even 1% of bad ground truth data, the resulting model is just going to be better. That's just a fact, right? Because that's how basically all of these machine learning systems work. Garbage in, garbage out. So less garbage in, less garbage out. Now, how diff does this, does the analysis to understand the truthiness and all that, we have to save this for another time. But let's just assume for the moment that diff does this, and keep in mind that diff models are deterministic, so the answer's always the same. Diff systems cannot hallucinate. Diff systems do not have SCS. It doesn't exist in diff systems because they're not stochastic. There's no part of stochastic whatever inside of a diff system. And in the white paper, we talk about this, is that if you have any amount of stochasticity in any method or embodiment of diff, it's not diff. It can't be diff because diff systems must be deterministic. And I explain the details of their determinism, but they have to be deterministic in both their They have to be deterministic in what I refer to as their refinition and their utility. So refinition is both training and iterative refinement considered in one word. So historically, the way the language models or any ML system is considered is you have training, which is you start with like a model that's untrained, and then you train it, and then you have a model that's trained, and then there's another step that is iterative refinement, and those are things like reinforcement learning, right? Because you can take a trained model and then do reinforcement learning and improve the training, but that's different than the initial training when you don't have a model. Now you could use reinforcement learning as like the first step, but it's very important to distinguish between these two categories. Is you have a model that is not trained, it's just the topology is set up and there's nothing, it's received no input. And then there is this part where you have the existing model and you are iteratively refining it. And you can do this through various mechanisms today. The two primary ways that you do this in machine learning right now is through reinforcement learning and supervised fine-tuning. Give me just one second here. Okay, so that concept of training a model and iteratively refining it, I refer to this as refinition. This is defined in the white paper, and this is very important because those two ideas are both related to model improvement. And generally speaking, people have considered them in two different categories, and that's part of the reason why we're in the state of suckiness that we're in right now, is that historically people have considered training for neural networks as a one-off, which is so dumb. Because science doesn't work this way. You don't just like come up with the, oh, awesome. Yeah, so I think I defined this word at some point, and Urs, I think, started to comment about the different aspects of refinition. Because our diff models, yeah, basically perform the refinition in those two phases. Is you start with a space where you have no training on a model and you send data to it, and then because our diff embodiment supports continuous learning, you can do this refinement over and over and over without loss of fidelity, which is a big problem with neural networks, and why it's like so challenging doing supervised fine-tuning. Because when you do supervised fine-tuning with a language model and you train it in a way where it becomes misaligned, you're cooked. The moment that a model has misalignment, you're done. You have to go back to the model that existed before. You can't. It's not like your car's alignment, where it's misaligned and you go to the mechanic and then it's like you fix the alignment. No. When you have a language model or a neural network that gets off its alignment, it becomes misaligned, you have to throw it away. There's no coming back from it because it doesn't support iterative refinement. With a diff model, if it became misaligned, you would just fix the bug and make it aligned. Think about it like software, is that if we did software this way, if we did software the way that we build AI systems, anytime your software system had a bug, you would just have to throw the software away and then start again. Can you imagine that? You go to build this new feature, and you got the feature and you put it out in the wild, and it turns out that it's 99% correct, but 1% it's wrong. And now you know that the 1% that's wrong can never be fixed. So you have to start again. That sucks. That's no way to do science. This is part of the reason why many of us are like pretty locked on language models not being the right solution, because of this alignment issue. So anyway, that's what refinition means. Refinition is both parts, the normal training and iterative refinement. And for a diff system to be a diff system, it must support determinism for both parts of refinition. It must. If it is not deterministic in both parts of refinition, then it is not a diff system, because it won't actually support reliable iterative refinement, and it's not diff. Super, super important. Then the next piece about this is it's the notion of utility. So rather than calling it inference, we changed the word of when you use a model to it being called utility. And part of the reason for this is that for diff systems, they can give you non-answers. They can give you exceptions. They can essentially say, I can't answer this. This is fundamentally important. This is also why language models are so cooked, is that language models rely on inference, and inference must give you an answer every time, even in cases when it doesn't make sense to give an answer, like division by zero. So if you give it the division by zero and it actually had to try to solve this, it would try to solve it, even if it's not solvable. What a diff system would say is, there is no answer to this. I cannot answer this. And so it won't give you an inference result. And that's known as utility. And utility is basically just, think about utility as the way you think about a function that can throw exceptions. Is that most of the time, the function will execute and it will give you an answer. But in some unusual cases, it will not give you an answer. Instead, it will basically throw up an exception and say, no, you did the wrong thing. You gave me something that's not answerable, and I will not give you an answer. It's critically important that deterministic systems support this behavior. Almost all mathematics supports this. Division by zero is one really critical example. Is that if we required to give an answer for all numbers in division, we would have broken math, right? And the reason for that is division by zero, it doesn't mean anything, or it means everything. There is no answer to this question. But if you're forced to give an answer, like inference systems have to give us today, then you would make something up that is nonsensical, and it would be wrong, right? And so think about it like this, is that if for inference results, right, let's say that the answer is between 0% and 100%, and it has to give you an answer, then it always will. And sometimes what you want it to do is say, nope, I'm not going to do that. When you try to do division by zero, it follows the same principle. And so rather than giving you what it should do, if it followed inference rules, is it would give you a numerical answer every time. But what these systems actually do is that this is actually an exception. And so it gives you NaN, not a number. It says it's not a number. But notice that not a number is not a numerical result. This is critically important. It's fundamentally important. It's something that is completely broken with inference that exists today in machine learning. They got this wrong. They got it wrong. And diff is not getting it wrong. Diff is getting it right. I mean, I don't know how else to say it other than saying, like, it's like the Roman Empire, right? A big reason why the Roman Empire fell is they couldn't represent the number 0. They got it wrong. And then so we advanced and we created a number system that supports the number 0. That is correct. That actually supports this. So the initial, keep in mind, this is all still early. We invented neural networks in the 1950s. It's only been around for 70 years. We screwed this up. This is just, you can't, so like with diff, part of this is me looking at the foundations of it and saying, nope, this is just wrong. We have to get this right. It won't work. And so this is another property of utility, and why it's not called inference is diff systems do not, yes, they did. Yeah, that's right. The people from India are, and not only responsible for that, I think they're also responsible for the invention of algebra. Is that right? Am I getting this right? So we fixed 2 problems now with diff. We fixed the training and iterative refinement problem with refinition by forcing it to be deterministic, because it can't just be deterministic on the training and not be deterministic on iterative refinement, because then you're cooked. And then utility is going to be deterministic as well, but utility is different than inference because of those exception cases. Is we allow it to have errors, and that helps us significantly for cases where we cannot give an answer. And oftentimes people will talk about this in the ML space, as they'll say one of the problems with language models is they're compelled to give an answer. Guys, it's not that they're compelled to give an answer. They have to give an answer. Inference is designed that it must give you an answer. It has to. There is no, you can't have a neural network do an inference pass and not give you an answer. And that's fundamentally wrong, because sometimes answers cannot be given because the constraints of the problem are wrong. And diff fixes this through utility. That's why we don't call it inference, we call it utility. And by the way, this has pissed off some of my colleagues, some of the people that have seen the white paper, because it's like it makes understanding the diff paper significantly harder, because I'm inventing these new terms that breaks the traditional nomenclature, but those terms have to be invented so you can solve this the right way. Okay. Anyway, this is my long-winded way of saying that the diff systems will be deterministic, and how they do their determinism, let's just put a pin in that for the moment, and instead just say they will be deterministic, and because they're deterministic, you can rely on this in a way that you cannot rely on a language model. Notice, very importantly, guys, language models cannot do this. You cannot have a language model do the pre-model data curation in a reliable way like you can diff, because language models are not deterministic. And so the reason why this is important is that if you were training 2 models with the same data, and you used a language model as the pruning mechanism, the language model would sometimes prune words or input here, and then it would sometimes prune and do stuff over here in the second version, but they wouldn't be consistent. And so then you might get different results for the model training, and again, that's creating more non-determinism, and now you have a more unreliable system. So you couldn't use a language model in this space to give you deterministically better results. Sometimes it would give you better results. Sometimes it would hallucinate and give you bad results. or it would have its SCS thing more precisely. Okay, let me pause for a second and just ask, does this make sense? Uh, Plastic designs, your question of can you let it use sources like Elsevier, ResearchGate, and Wikipedia? As far as like, are you asking, can it be used as a pruning mechanism to get the bad information out? Yes, you could. We haven't built it yet to work in the natural language space, but that's part of our charter. And so at some point it will support that. So this is probably a couple years out before we support that behavior, but it's on the horizon. Yes, I guess the long-winded answer is yes, it can eventually, and it will eventually support the pruning of and false information in any domain. I want to also be clear about one thing, because I don't want you to oversell this. We don't yet know the constraints of applicability of diff in different domains. Okay, so what I'm trying to say is, in the space of hard science and programming languages, I can tell you pretty much definitively the diff can be applied for the entire space of programming languages, the entire grammar, and it will essentially give you full coverage. It's not to say that it's going to catch everything that's wrong, but it will basically have full coverage. And you can design diff systems so basically it basically has almost no false positives. That it's almost always right. Again, can't guarantee that it will always be right, even with it being deterministic, because it could have the way that it's trained and the way that it uses like Byzantine consensus, it could still get the wrong answer, but you can fix that as a bug. But what we don't know is limitations that it may have in these different domains. So I don't know how far you can go down the training of diff models in certain knowledge systems. That's an open question. So this is me just trying to clarify for plastic designs, is that we can build it for natural language and we can build it specific to know facts about different domains and have it learn more facts and actually understand like what is fact and what is not a fact. But it will have limitations in its knowledge. It's unlikely that any diff model will be the knower of all things, is what I'm trying to say. But a good way to think about it, I think, is that if diff tells you that something is incorrect, you can design diff systems so that it's pretty much always right. That if the diff system basically says this is nonsense, it's going to be right about that. But you can't trust that it will always catch all of the things. That's something that we can't promise. Okay. The next area that you can use diff is actually in model training. So now you're actually in the training of the model, and as it's basically coming out with its answers that it thinks are correct, you can send that to a diff system, and then the diff system can analyze that and say, no, that's actually wrong. I know that it's wrong because I have this understanding of knowledge that you don't possess, and it can say, don't allow that to actually be used. And this can impact the training of the language model. So you can kind of think of it as like this, is maybe maybe the answer, like again, there's dozens of different ways that you could use this here, but maybe the answer that the language model is giving, it thinks is correct, so it won't do back propagation, right? It won't actually do the error correction on it. And then diff can come in and say, no, 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 you're actually wrong. This is not a correct answer. And here's the correct answer. The correct answer is this. And then once diff provides the correct answer, then the language model can say, oh, whoops. And then it can do error correction on that. Alternatively, the diff system can also come in and identify cases where it is correct and the language model thinks that it's wrong, and it would try to do error correction on something that doesn't need error correction, and the diff system can stop that from happening. Right? So, again, when we're talking about graphs, the way to think about this is a forward edge. It's the input into the training of the model, and diff is pruning. When you're actually doing the actual training of the system, this would be considered a cyclic edge, right? So it's basically creating a cycle here that didn't exist. And then the third way that you could use diff is it can be used to create this back edge. So I think this is kind of the easiest way to think about it is this is a forward edge, this is a cyclic edge, this is a back edge. That's kind of how it sits in my head anyway. And so what the back edge is that the language model now is trained and it's doing inference and it's trying to give you an answer, and diff intercepts the answer and then it says that answer is wrong, and it sends it back to the language model. And once the language model knows that it's wrong, then the language model can fix the answer. But oftentimes language models don't know that they're giving the wrong answer. Otherwise, they wouldn't have given that answer. But once informed that they have given you the wrong answer, language models can actually be really good at fixing that. This is something that we have seen in en masse, applying diff to LMs. And so this does create a cycle, but it's degrees of separation. Is it actually leaves the language model, goes to the diff system then sends it back. The language model then generates a new answer and then goes to the diff system, and the diff system essentially acts as a verifier. So the way to think about this is like this is the discriminator of generative adversarial network. So if you're familiar with GANs, generative adversarial networks, it's functioning here as the discriminator in a GAN. So these are the three ways at a very high level that diff can be used to improve language model fidelity today, right now. And now I want to just show you an example of how we actually did this, and you can see the results. So basically, we did analysis of the, what did we analyze? The Claude C compiler that was written in Rust, I think. And Mentor did its utility on it. And it found a whole bunch of things. And one of the things that it found, and keep in mind this was written by Opus 4.6, so supposedly this is, at the time, this is a state-of-the-art language model, especially for code. And this was the original code, and then diff basically caught this, sent this back to the language model, and said, this code sucks, make it better. Once it's informed that it's wrong, the new code that it generated is this. Yes. Yeah, JB, you're totally getting it. You're completely grokking it now. That's exactly right. Is you can think of it as a verifier, and again, this is just one use case of diff. We're just talking. What we're talking about here in this case, where the language model is generating the output and then diff is correcting it, the only thing we're talking about in that particular case is this one scenario. That's it. And there are 3 scenarios here, and this is just for diff on language models. Diff doesn't have to be used on language models. Diff can be used on whatever the hell you want it to be used for. Diff can be completely standalone. So even just being applied, yeah, man, right. I mean, Chris is onto something there. This is it just being applied in this small space, and you can see very clearly, this is, by the way, this is not a fake example. This is a real example. This is Opus 4.6 code that it generated. This is diff analyzing that code, saying this code sucks, and Opus 4.6 obviously didn't think this code sucks. Otherwise, why did it write it, right? And part of what you need for a system to do this is you need a system that has all of the qualities that diff has. That it's hyper performant, so it can function at scale and analyze hundreds of thousands of lines of code or millions of lines of code in literally seconds, right? And the way diff is designed is it can have constant execution overhead. That's O of K, and that's O of 1. It doesn't get faster than that. To give you an example, the language models that exist today, the inference that they have, their overhead is like best case, it's O of n, but more likely it's more like n squared or something, or it's something that's significantly larger. And diff is going to roll in at O of 1. Now, I'm not bashing on language models. Language models are super awesome, and they're a huge breakthrough, and they allow us capabilities that are critically important due to their stochasticity, right? Because diff systems are not stochastic. They don't really do ideation very well, but they're really good. They are really good at acting as fact checkers, or as anomaly detection systems, or as, gradients of truthiness, right? It's like they're really good at this stuff, where the way that I kind of describe them is diff can be the telescope, whereas language models are the microscope. So you wouldn't use a microscope to scan the universe, because that's not going to work. You would use diff to do that. Diff can scan the universe to find the planet that you're going to go live on. And then once you find the planet, then you can pull out the microscope, right? Anyway, so now we saw this example, right? How does this go back to SCS, right? Now we can tie this all together. This is how it integrates with the SCS stuff that we saw before. Remember how I said that this entire space, there are gradients of truthfulness? The example that Claude came up with, this is a truthful answer. This is correct. This answer is right in terms of its logic. It's just this code sucks. So its goodness or its truthiness on other dimensions like readability or modularity are very low. So this is one of the spheres that's not in the center. It's not a hallucination, or it's not an error. But what diff does is then it levels this up. It takes the LM answer that's over here, and then with its refinement, it moves it closer to the center. And what you end up with is a better answer. And that's awesome, Michael, because literally I'm pretty much talked out at this point. And thanks for being part of the discussion. That's super great. Anyway, I think that is it for today. But hopefully this makes a ton of sense and gives you guys an entry point into the power of diff and how revolutionary We really think that it is, and it's going to be, and you can see concretely how it would be used and how it is used, right? This example here, this is a real example of using diff in the scenario that I literally described, and how it relates back to the whole fundamentals, the principles of the field of machine learning and spherically constrained stochasticity. So it's like, this is it. Yeah, man. Yeah, I love it. Alexander, no, it's great to have you as well, right? I love that. Despite all the negativity and all the people that told me I was out of my mind creating GTT, and that like people are not gonna sit around and listen to science and tech lectures for hours on end. I thought something totally different. I thought absolutely they will, because there are other nerds out there that want to change the world just like I do, and we're doing it. We're doing it. This is a community, and we literally are building out the future, and I couldn't do it without you guys. So that's it for today. I need to get to work on this data camp thing, otherwise they're going to fire me. But let's hop over and continue the conversation over on Discord. I'm going to drop the That's awesome, Chris. Yeah, and likewise, Chris, it's that is a cyclic edge, my friend. Is I actually could listen to you talk for 24 hours straight myself. Is Daj, what is diff? Diff is a new type of machine learning that we've invented. It stands for deterministic intent folding, and you can find more about it on our YouTube channel. And you can hop on this Discord, and there's lots of discussions about it. But that's, yeah, what we were describing. This is the talk I gave at Microsoft Research a couple months ago, and it's part of what I teach at this place, and what we build at this place. Awesome. So thanks, everybody. Oh, let me drop one more thing. One of the things that I absolutely love, and I love it for the reasons that I really want us to get over 100 members, just because that's going to give me warm and fuzzy. So if anybody enjoyed this conversation and wants to hear more of this stuff, if you're not already a member on our YouTube channel, I will, Chili, I will post these slides somewhere. Right now they're not currently available because people were telling me that they didn't want this to become publicized yet. But I think I don't know that I care. I'm ready to publicize them. So I'm going to make them public. I'll update the website. Once we get goju.dev working, we'll start to clean up our website quite a bit. But I'll make these available somewhere. So thanks, guys. And keep in mind, joining as a member, it's only like $2 a month. And it gives me warm and fuzzies when you guys do this. It's like less than the cost of a coffee, and I just love it. So please join both things if you can, but minimally the Discord. Discord's free, and you get to be part of the discussion. And join as a YouTube member if you can. And if not, then we'll just see you on the Discord. So let's hop over there now. Keep going, keep growing.